What is the first thing that comes to mind when you think of the word fungi? The mold on old bread, or the infection you're too afraid to see the doctor about? Funguses often have negative connotations attached to them, but luckily, the fungus kingdom has about 3.5 to 5.1 million different species of fungi, including single-celled organisms and multiple-celled organisms, which is the main focus of the video. The biodiversity of these eukaryotes provide direct, indirect, aesthetic, and ethical services for the living, as they are incorporated in many relevant environmentally friendly alternatives and also play a major role in the ecosystem. Decomposition. The primary function of fungi is the decomposition of organic materials, and in doing so, creates a balance in the food web and ecosystem. Fungi are non-photosynthetic organisms and do not contain chlorophyll, meaning they can't photosynthesize like regular plants, making them heterotrophs, specifically saprophytes. However, unlike regular animals that digest food inside their bodies, fungi digestion happens outside the body, and they store the smaller molecules of nutrients in the glycogen rather than starch. This process is called extracellular digestion. They transport exoenzymes out of the hyphae and onto the surface of food, branches, leaves, dead animals and insects, and etc. They metabolize the complex organic compounds, which are molecules that contain carbon atoms that are covalently bonded to hydrogen atoms. We can also see these bonds in glycogen and starch. They convert them into soluble nutrients like simple sugars, nitrates, and phosphates. All of these processes make fungi a key player in the nutrient cycle. From the ecology unit, we learn about assimilation, ammonification, and nitrification. When an organism excretes its nitrogen-containing urine and organic nitrogen compounds in feces, the urea, uric acid, and feces all become substrates for ammonification. When an organism dies, the nitrogen in the tissues is also in the form of organic nitrogen. Fungi breaks them down and convert them into inorganic nitrogen, which is ammonium, and through nitrifying bacteria, it turns into nitrates that can easily be taken up by plant roots. Fungi also ties in with the carbon cycle and can even reduce the effects of climate change. Living organisms respire through a process called cellular respiration by combining glucose with oxygen, which is highly reactive and rips apart the glucose to gain electrons, creating H2O, CO2, and energy. When they die and get decomposed by fungi, they will release the carbon dioxide back into the atmosphere. However, fungi can also store carbon. Mycorrhizal fungus is a symbiotic relationship that forms between the fungi and the root system of a plant. They can sequester carbon in the soil by receiving carbon from the plant host and use it to build the hyphae that extends into the soil, where they will deposit and sink that carbon, delaying the release of greenhouse gas in the atmosphere. A Swedish study actually showed that 50 to 70% of carbon stored in soil is from the tree roots and their fungal partners. But let's take a closer look at the structure of fungi, especially the network of hyphae called mycelium. The article by Scientific American talks about how we have harvested the power of mycelium through technology and turned it into biodegradable materials as an alternative to crude polymerized structures in a variety of products. The damage polymers have done is irreversible. It takes thousands of years to decompose, and the microplastics and chemical compounds can even end up in animals and humans' digestive system and bloodstream. BPA mimics female estrogen, influencing normal bodily processes, and can cause early puberty, alter breast development, and increase the risk of prostate and breast cancer, and more. They, along with microplastics, will bioaccumulate and increase in concentration in the organism's body and in the environment, traveling through the trophic levels. Unlike mycelium packaging, which is fully biodegradable and can even be composted at home, it biocontributes to the soil and has proven to enhance plant growth. It can be eaten by organisms without causing harm, but will have no nutritional value. To create these composites, they upcycle agriculture waste such as hemp herds and combine them with mycelium, allowing it to grow in a pod for 7 days and dry. These byproducts are often burned, generating large amounts of carbon dioxide and other greenhouse gases. By using these substrates for mycelium products, you're reducing the emission rate. The process also relies on the growth of materials rather than extrusion and heat extractions, meaning that we are less dependent on burning fossil fuels and use less electricity. Fossil fuel combustion can cause acidification, changing soil and water pH, leading to the death of many producers and aquatic animals, along with corrosion of metals and stone. Furniture giant IKEA announced that it will replace its regular styrofoam packaging with eCradle, which is mycelium packaging, for all of its products, proving the credibility of this industry. Mycelium might also provide a solution to one of the biggest global crises and climate change contributors, the agriculture industry. This industry creates mass land destruction and habitat loss by clearing out forests and filling wetlands, removing the carbon capturing abilities of wetlands, preventing nutrients from getting cycled. These mycelium are all grown in vertical farms, which are growth chambers that mimic the conditions of natural soil. This design choice prevents fragmentation, which destroys all three levels of biodiversity that can determine and support a species' survival. The quote-unquote meat can also be prepared in just 9 days compared to the months and years for farm animals, which requires large amounts of fertilizer that can lead to eutrophication. The fertilizer runoff can increase the growth of aquatic producers such as algae, promoting shorter lifespans, which means faster deaths and more decomposition. And more decomposition results in more cellular respiration, mentioned previously in the video, which requires large amounts of oxygen, ultimately resulting in dead zones that kills aquatic organisms and disrupts the ecosystem and food web. It's sustainable when compared to traditional meat farming practices and also a highly demanded fiber and protein-rich plant-based meat product that can be the next step to an environmentally conscious food market. Learning about the negative state our Earth is currently in, from news reports in school, made me reflect on all my contributions to these effects. So I went searching for ideas that can combat these challenges, which led me to fungi. The possibilities that come with these life forms are infinite. With the advancement of fungal studies, we can further improve on mycelium technology and research about the role fungi plays in nutrient cycling in correlation to all the major environmental changes on a deeper level. This is only the beginning, as there are still many limitations restricting us from fully benefiting from fungi. As an example, the lack of attention from the general public, who refuses to educate themselves. Evidence suggests that fungi has existed 1 billion years ago and have continuously evolved ever since. We need to take advantage of these opportunities and start focusing on these powerful organisms known as the fungi.